This is the second video on this topic, and it's in the same class, so it's business performance management. And I want to look at just a few outlying ideas, just some ideas that are associated with this process of performance management and performance measurement. Let's start with this idea of Six Sigma. Now, it's often mentioned in the context of performance and how well organizations are performing. Essentially, what it is trying to reduce the errors and the problems down to zero. It's having no tolerance whatever for defects. It's trying to reduce it as far as possible, so that the probability of having an error is very, very, very small. Six Sigma, the name comes from the normal distribution. We have the mean. If it's a normal distribution, the mean is the line of symmetry down the center, and we would measure off from the mean in standard deviations. So, for example, 2.96 standard deviations on either side would be 99% of the probability of something falling in that region, 99%. Well, Six Sigma, you can imagine, it's a very small one indeed. It's as close to zero defects per million opportunities, DPMO, as is possible. So it's as close to zero per million opportunities as possible. So the possibility of defects is almost eliminated. And it's important to realize that a company working to this sort of tolerance level must have a lot of confidence in its own procedures. It must have good management style. It must have efficient capital. It must be well designed and well laid out. There must be good quality control right throughout the system. And it fits in with total quality management and the idea of making sure that the quality is as near to perfect as possible all the way through the system, that the workers are adequately trained, that the dispatch is efficient, that the office routines are efficient, and there's good communications throughout the system. Everything runs to peak efficiency. So there are nearly no defects per million opportunities, DPMO, as possible. There are various models that you can look up in the context of Six Sigma. Here's one called DMAIC, and this is a closed loop business improvement model. Closed loop means it's internal. It's looking at everything within the organization, so there's no external influences or nothing to upset the model. It's closed loop. It feeds on itself. One of these processes runs to the next, and when it gets to the end, it goes back to the beginning. It's a closed loop. And the DMAIC model is defining, measuring, analysing, improving, and controlling. So this approach to Six Sigma is defining the objectives, defining the tolerances, or defining the processes, then measuring them, and then analysing the measurements, and then improving on the performance. Whatever the measurements tell us, after the analysis is conducted, try to improve it even further, and then control the process and go back and look at it again, define the process, measure it again, analyze it again, improve it further if possible. And in this way, the whole organization, all the processes within the organization are moving to almost perfection, but so also is the organization. So the organization is becoming more efficient. And I suppose that's the underpinning idea behind the Six Sigma. There are limitations to it, of course. lack of integration amongst the various Six Sigma projects across the enterprise. It could be that instituting Six Sigma on a particular process knocks another one off. The other one can't run to that sort of capacity, or it can't run to that degree of perfection. So there's a knock-on effect. The inputs into one process have to be perfect for the process itself to be perfect. Well, that means the process before that has to be perfect as well. So there are knock-on implications that can run right throughout the organization, which some would say is a very good thing because it improves the whole performance of the organization. But others would say, well, you only need one part to break down or one part to malfunction, and it's going to bring down the whole edifice, the whole Six Sigma edifice. Because if one part starts to produce faulty products that are inputs into the next process, then the next process will collapse, and they may produce inputs into the following process, and that will collapse, and so on. So there are limitations to it. And it is a very, very ambitious program to try and eliminate all defects. That's very ambitious. The failure to institute the roles required to support the methodology. Sometimes companies just say, yeah, we will now adopt Six Sigma. But there is no champion for Six Sigma. There is nobody who is responsible for it within the organization. There's nobody who is working towards this objective continuously in the process of analyzing and measuring and defining and feeding it back and trying to control the system. It needs attention. It needs work. It's not just going to happen. It needs to be made to happen. Now, we'll encounter Six Sigma elsewhere, and it's worth reading up about it yourself just to find out about Six Sigma. But in this class, that's all really I'm going to do on Six Sigma. Now I'm going to move on to another topic. And we're going to talk about the architecture and applications that are required for the business process management system to work effectively. So what sort of design, what sort of architecture, and what sort of applications are required? Well, we could start with what we need to do. We need source data. Before we can measure anything, we need data. So we need to source data. And generally speaking, we take the data and put it into a database, and then we process the data in the database, or alternatively we download it into specialist applications, computer applications, let's say, that will work out trends or economic order quantities for the stores, or whatever it is we're interested in calculating. But we start with the source data, then we move to the database, and from the database we can extract information as we want and use that to make decisions. We then have applications that we can use, such as spreadsheets, text processing, communications, statistical analysis. So we've got a whole series of applications that can help us in the analysis of the data that's perhaps extracted from the database. The company database, which holds stock levels, numbers of people working there, the backgrounds to the people, their skills, competencies, expertise, the amount of capital the business has got, the amount of resources, total resources it's got in terms of floor space, and so on. So the database can hold all of this information, and it can be shared. It's a central facility that can be shared throughout the organization, so managers can get access to it and can process the information. We also have enabling technologies that help the organization in terms of acquiring more information and refining the existing information. So we obviously have the internet, and we've got communications facilities on the internet. We've got portals, which are sites dedicated to a particular perhaps industry or to a particular product. And these will contain valuable sources of information. So you might have a site related to people who work with copper or who work with silver, or people who are interested in fashion items. So we'll have portals, and those portals can contain information which can be taken back and even included in the database for the company, so that the company can integrate that information into future calculations. And also, of course, hardware, which enables the technology to take place. The hardware, generally speaking, tends to be computerized nowadays with perhaps a local area network, and the local area network contains the software that's required for detailed processing, including access to the database itself, which may be stored on a server locally within the business. We have the user interface, of course, which is also important, which could be a spreadsheet or a word processing package, or it could be the internet, it could be a browser on the internet. So we've moved all the way from data source to the user interface. And that's important. It's important that we have, if you like, a sequence, building it up. So we have finally the user being able to access the information and make sense of it. Then we have the business process management architecture. Well, we have the system architecture. One of the features of the system is having the database, which I'll talk about or mention as we go through. The database contains all the relevant information of the business. It should be stored centrally, it should be backed up, it should be secure, it should be free from attack, it should be confidential. Only people who need to know can access it. It might be a read-only database, that they can't enter anything in case they upset the database or distort it. Previous versions should be contained on the server, and it should also be backed up onto a separate hard drive, just in case. So we have the systems architecture, which will include this type of facility. And in the system architecture, we have the logical and the physical designs of the system. The physical design of the system is how the plant is laid out, how the work is conducted. That's the physical side of production. And the performance management structure should look at how logical is the physical layout of the business. How are the offices organized? How do the offices link to each other, and how do the people in the offices share information? How do the offices perhaps link to the shop floor? How does the shop floor link to the stores? And how do the stores link to the office? It's a physical design which should be worked out carefully to facilitate efficiency. But there's also a logical one. A logical one is one where there is, if you like, virtual contact. This would be online contact, and that should be logical as well. It should be easy to communicate throughout the system and interrogate the system. And that should be done logically, and it should be done straightforward. So the business performance management system needs three components in order to contribute to the successful implementation of the strategy. First of all, there's the database. I just said earlier that the database is of critical importance because it contains centralized knowledge of the business, the information about the business that's been accumulated from experience and practice, and has been refined by the experiences of managers and the marketing department and whoever. So they have updated the database, and it contains recent thinking, but it also shows trends and patterns, and not only that, it shows how to make the product, what raw materials are required, what's in the stores, and how the raw materials flow from the stores into production, and then from production from one part of the production system to the next until it gets to completion. The database can be very comprehensive and hence very important. So that's quite a vital part of the applications part, the overall structure of the performance management system. The existence of a good and well-maintained database is central. The application tier, well, the applications are what can be used to make sense of the system itself. Having data coming from the database is okay, but we need to interpret that, we need to understand it, we need to present it, we need to discuss it, and we need facilities to do that. So we have access to various applications, spreadsheets and so on. And there should be some sort of user interface that enables the users to access the information that's stored. If it's on the server and we can't get to it, then it's of no use to us. If it's on the server, we need an interface. We need to be able to connect to the server and access the information. Now, we've talked about the database in considerable length, so I'll miss out the database and now jump to the applications part. So the applications, well, we have various applications of data. The data can be used in a variety of ways, in planning, in budgeting, in forecasting. Of course, it'll need the input of the appropriate software to do this. It'll need a structure with people with skills who can interpret outputs and can refine the ideas. But as a part of the starting process, if you like, the starting part of the business process management system, we would need information to enable us to budget, plan and forecast. But we also have a desire to look at profitability modeling and optimization. What's the break-even level of output, and at what point will profits peak, and at what point will sales revenue peak, and how sensitive are sales to price adjustments. And we need to be able to do some manipulations, some calculations to illustrate what we're finding. And of course, scorecard applications. The balanced scorecard is something we dealt with in a separate video in this class, but that's become more and more important in the this whole drive to look at the performance management of a business, to see how well the business is performing, and to look at it in the context of the requirements of a balanced scorecard. I won't go into it now, we've done it before in the other video. And of course, financial considerations are very important. Working out profitability or unit costs, or looking at budgets and budgetary control, and so financial information is of crucial importance, and that's another application of this whole architecture, the use of computing, an intranet, a LAN, the use of all of this. It can help to facilitate all of these parts, which are requirements of the process management system. Of course, also there are statutory and financial reporting requirements. The tax people need a report at the end of the year to show what profits were made, so tax could be imposed. There are statutory requirements how the accounts are drawn up and who signs the accounts, and the whole issue of financial reporting and stewardship accounting, to make sure that the accounts are legal and honest and fair. So the architecture also requires a user interface. Having all of this information, which we're going to use for process management, having all of that, looking at performance management and looking at the various processes and looking at the overall flow of production in the system and the office routines, and it's a very complex set of relationships. Even small companies have quite complex relationships, have several things running at the same time, have the accounts department running on some aspect of budgeting, and another department making something, and another department trying to innovate and change and meet particular customer requirements and so on. So even small organizations or medium-sized organizations can be very complex. And the user needs an interface. It needs to be able to access the information and get the information specifically that he or she is interested in. They may not be interested in all of the plethora of information stored on the server. They're only perhaps interested in some specific piece of information. How do we make this product? What raw material do we require? What machines do we require? How long will it require on each machine? And so on. It might need very specific information. So the user interface is the bridge between the performance management model, or if you like, the process management, however you want to look at it. Looking at those applications and the end user. The end user is the people who are going to ultimately access and use the system. The web browser is currently the primary tool for accessing information. That is a very important piece of software in this whole story. Having powerful web browser that can access the server and bring up the information that the user wants and bring it up in a fashion that makes it usable. That's a very important facility. But spreadsheets are popular also, and spreadsheets can be used for all sorts of computational needs. And spreadsheets are easily understood, they're widely available, so the user could access the database and download part of the database into a spreadsheet and do some calculations, work out averages and trends, and even do small regression lines or whatever is required. So there's a possibility of using spreadsheets in this case. The whole system should provide guidance to the end user. It should not just provide the information, the hard information that the user was looking for, but it should, through the analysis of the data, provide guidance to the end user so that better decisions are made and efficiency is fostered through this whole approach. So that concludes our talk on the performance management system, the business performance management system, looking at various processes right throughout and looking at the complexity of the system and looking at the type of applications that the performance management system requires, and also looking at the type of facility, computational facility and storage facility that the system needs, mostly in terms of database, access to database, and the analysis of information contained in the database. But that's all I'm going to do in this session, so we're going to leave it at that and say thank you for watching.